This video is about the shortest distance from a point to line. Look at this diagram. We need to figure out the distance from P to this Q. Q is the projection of P on the line L. We do know PQ is perpendicular to this L. We got to use this property to figure out the shortest distance. The line r equals 1 to 0 plus lambda -1, -1, 1. And the point P, 0, 1, -1. Find the shortest distance from P to the line. We will label this Q using parametric form of the equation of this line. X equals 1 minus lambda, y equals 2 minus lambda, z equals lambda. Label 1 minus lambda, 2 minus lambda, and lambda. For the PQ, coordinate of P is 0, 1, -1. So vector PQ equals 1 minus lambda, 2 minus lambda, and lambda, minus 0, 1, -1. 1 minus lambda, 1 minus lambda, and lambda plus 1. Since PQ perpendicular to L, so PQ dot the direction vector, this is a direction vector B, -1, -1, 1 equals 0. Therefore, 1 minus lambda, 1 minus lambda, lambda plus 1 dot -1, -1, 1 equals 0. -1 times 1 minus lambda plus -1 times 1 minus lambda, then plus 1 times lambda plus 1 equals 0. -1 plus lambda minus 1 plus lambda plus lambda plus 1 equals 0. 3 lambda minus 1 equals 0. Lambda equals 1 over 3. So the length of PQ equals square root. We will plug in here. 1 minus 1 over 3 square plus 1 minus 1 over 3 square plus 1 plus 1 over 3 square. Simplify square root. 4 over 9 plus 4 over 9 plus 16 over 9 equals square root 24 over 9. Don't reduce because we need this square root of 9 out. That equals, this is a 3. Square root of 24 is a 2 square root of 6. This is the shortest distance from P to the line L.